Hello, everyone. My name is Paulo Dela Rosa. Okay, so mathematics teacher here in the Philippines. So today I'm going to discuss some topics that is related to my major, which is mathematics. Okay, so I will give some introduction to myself. Well, I have graduated since last 2015 at the Bachelor of Secondary Education, major in mathematics in San Pedro College of Business Administration in San Pedro, Laguna, Philippines. And I have 7 years of teaching experience here. So that is why I am very confident to present my demo teaching for you. Okay, so let's start. So let's have a short drill first. So, okay, you are going to answer the following questions that I will give to you, and it will be test if you are reviewed the last topic you have encountered last school year. Okay, so start. Okay, so identify the degree of the following polynomials. So you're going to identify what is the degree of those polynomials. For letter A, we have x cubed plus x squared minus 2x minus 1. So what do you think? What is the degree of this polynomial? Okay, very good. So that is 3. Next one, letter B, 9x minus 3. Anyone? Yes. Okay, so very good. That is 1. Why is it 1? Because we're going to look the variable first, and if the variable has alone, it is alone, it means that the automatical or the imaginary exponent of this variable is 1. Next, letter C, we have 4x squared plus 2x minus 1, that is, okay, that is 2. Fourth one, 6x squared minus x plus 3x cubed plus 4. Okay, that's great. The 3. Why is it 3? Because the highest value or the highest exponents that we have in this polynomial is 3. That is why this is the degree of the polynomial. Okay, so next we have 6 for letter E. 10 plus x minus 2x squared plus x cubed minus 5x to the 4 plus x to the 6. Okay, so I'm going to answer the question, why is it 6? Next, we have 81 minus x cubed plus x. The degree is? Very good, that is 3. Again, for letter G, we have 3x cubed plus 2x squared minus x plus 4. That is? Okay, that is 3. And last one, x plus 1, the degree is 1. Okay, so I'm going to answer your question, why is it those numbers is the degree of the following polynomials? First thing is, you're going to remember that if the highest value or the highest exponents that we have in a certain polynomial is, for example, for that is number 3, that is the degree of the following polynomials. So if there is so many exponents here in the polynomials, you're going to consider the highest value of the exponent. Okay, so if you choose the highest value of the exponent, that is the degree of the exponent, even though it is located in the last part or in the middle part. As long as it is the highest value of the exponent, that is the degree of the polynomials. Like for example, for letter E. Okay, so we located the x to the 6th power at the last part of polynomial. But this is the degree because the polynomial, the exponent of itself is 6. Understood? Okay, let's start. So let us proceed. Let us have review first. So you're going to find the value of x. Also, I know that this is very simple for you to identify the value of x because it was already discussed last year in your grade level. So for letter A, we have x minus 9, that is, okay, that is 9. Next, letter B, we have, okay, negative 5 for x plus 5 equals 0. How about letter C? 2x minus 4. Okay, that is positive 2. Next one, 5x plus 5, that is negative 1. How about this one? X squared minus 36. Okay, very good. That is 6. How about letter F? We have, okay, 12. And for letter G, we have 1/2. And for letter H, we have, very good, negative 4. So simply as that if you're going to find the value of the following x, is you're going to transpose, or you're going to use the method of cancellation and dividing both sides by the coefficient. Okay, so for example, in this letter G, so 2x minus 1, we get 1/2. Why? Because we are going to transpose first the negative 1 into the right side, so it will be positive 1, and then since the coefficient of the variable is 2, so divide both sides by 2, it will be 1/2, positive 1/2. Okay, so let us proceed. So do you have any idea about the meaning of relation and the function? Okay, none. So I will give you some trivia and some information about the relation and the function. So relation, it is a set of ordered pairs in terms of mathematics, okay? Because we know that in dictionary that the relation is a commitment of between two persons. So in mathematics, it is the same as meaning of that, but in a mathematical way, because it is a set of ordered pairs. Because in ordered pairs, we have two numbers here, and that two numbers is having or have a relate or commitment with each other. Okay. Next, we have function. It is a relation in which each element of the domain has an exactly one element. So meaning to say, if the relation is a set of ordered pairs, those relationship or those relation, if we combine, if we combine it in a certain element, that is a function. How? So we'll see. Okay, so given the following ordered pairs, identify the set of domain and the set of range. So I know that you are familiar with the domain and the range. So now let us continue. We have the set of ordered pairs 3, 2, 5, 1, 7, 0, 9, and negative 1. And also we have 11 and negative 2. So how can we identify the domain and the range, or the set of domain and the set of range? Okay, so the domain here in the given set of ordered pairs is 3, 5, 7, 9, 11. And for the range, we have 2, 1, 0, negative 1, and negative 2. Why is it? Why the domain is 3, 5, 7, 9, 11? Because domain is the values of x. So let us remember that the values of x are located in the left side of each set of ordered pairs. So if we have 3, 2, meaning to say if 3 is located on the left side, that is the domain, and domain is the values of x. Same goes by 5 and 1. So 5, we have 7, we have 9, and we have 11. So 3, 5, 7, 9, 11 are the values of x. That is why it is the set of domain. And the range are the values of y. We have 2, 1, 0, negative 1, and negative 2. Do you understand? Okay, so let us proceed. So for now, we are going to discuss the first module of the subject of general mathematics. Okay, so what's new? Okay, so before we proceed to our discussion, I'm going to give you an activity, and for the general instruction is you're going to answer all activities on this module. Use separate sheets of paper for your answer. So for activity 1, grouping and constructing. Answer the following by using the indicated build table in each number. Okay. List down the domain and range of the function described by the ordered pairs below. Okay, so in your module, okay, they have a table that containing a set of ordered pairs. So you're going to identify which of the following set of ordered pairs are domain and range. Okay. Okay. So after you finish those activities, so I will give you 5 minutes to do that. Okay, class. So we have done in your first activity. So let's start for our discussion. Okay, so what is it? So as you can see in my presentation, we have 2, 5, 10 on the left side, and we have 6, 15, 30 on the right side. So we all know that function is represented by set of ordered pairs. So as you can see, function can be represented by ordered pair. So that was the earlier we have discussed the set of ordered pairs. So meaning to say, function can be represented in a set of ordered pairs. So function is a set of ordered pairs if there is no ordered pair have the same domain. So meaning to say you're going to consider that set of ordered pairs is a function if and only if there is no ordered pairs have the same domain. So there is no repetition in the domain part of the set of ordered pairs. So if there is no repetition, that is a function. And if it having a repetition, that is not a function. So remember that. So example number 1, determine if 2, 6, 5, 15, 10, 30 represent a fraction. Okay, and we are going to use the mapping diagram. So that is the mapping diagram. We all know that 2, 5, and 10 are the domain, and 6, 15, and 30 are the range. So let us see, or let us look the domain part. We have 2, 5, 10. Is there any repetition of number here? Okay, very good. No, or none. Because we all know that 2, 5, and 10 are different from each other. So that is why we call this set of ordered pairs are function. Okay, next. Function can be represented by an equation formula. How come? Because equation may represent a function if all possible values of x, there is a unique value of f of x. Example, determine if f of x is equals to 3x squared represent a function. By the way, class, this is an exponent, okay? So I don't know how to use I don't know why is it formula in this presentation cannot be applicable in this type of formula. But I will inform you that this number or 2 is an exponent rather. Okay. So solution, in order to find the coordinates, we must assign some values of for x and get the corresponding values of f of x by substituting the value of x in the equation. So here is the table. So if the value of x is -2, and we're going to substitute here in the formula, we're going to get the f of x of 12. If -1 is the value of x, we have 3 for f of x. And if you're going to substitute +1 in values f, we have 3. And same goes by with this one. If the value of x is 2, the f of x is 12. Next. Function can be represented by a graph. So the vertical line test can be used to determine whether a graph represents a function. How come? Okay, let us observe the following graph. Okay, so in the first graph, we call it a function. On the second graph, we have a not a function. And for the last one, we have not a function. Do you have any idea why those two, why the second graph and the third graph not a function? And the only first one is a function. Yes. Okay, very good. So we consider this is a function because we use vertical line test. And if the vertical line test meets once in a graph, that is a function. Meaning to say, if the vertical line test meets more than one or twice, that is not a function. Like for this example, for number second graph, we have a parabola here. Okay, and the vertical line test passes through to the parabola twice. Meaning to say, this parabola is not a function. Also, we have a graph here. We have a shape of circle here. And we use vertical line test. So the vertical line test meets twice. We have 0.1 here and 0.2 here. So that is why not a function. Why? Why is it not a function? Because meeting a twice of vertical line test in a graph, it means the domain has a repetition. So as I said earlier, if the domain has a repetition, okay, that is not a function. So in a graph, okay, if you can see the graph and we use a vertical line test, and it will shows that it will meet more than one or twice, two or more, it means that is not a function because the domain has a repetition. Okay, so for your activity, before we proceed for your activity, let us remember that the vertical line test is used only for the graph if you are going to determine if it is a function or not a function. And let us all remember that in a certain polynomial, we are already considered that is a polynomial is a function or not. How? Okay, if the degree term of a polynomial is an even number, automatically that is not a function. For example, is the highest degree of a polynomial function is 2 or 4 or 6 or 8 and so on and so forth, that is not a function. How? Now, if the polynomial has a degree, if the highest degree term of a polynomial is an odd number except 1, that is a function. Okay, so let us remember about that. Okay, so for your activity in your module, activity 2, okay, so you're going to complete the table of values for the given functions below and graph. Okay, and that is for your activity. Okay, so thank you for listening for my teaching, and hope you understand my discussion for today. Okay, so thank you and God bless us all.